Welcome all for revision session for learning analytics tools. So we will begin without wasting much time because we have so much to cover and very little time. So we will not be waiting for others to join. How we'll just begin the session, right? So, what I'll start with revision of main focus of today's session. I have kept on numericals and few of the what you can say, few of the like encoding, one hot encoding, binary encoding, all those muddy points which you had mentioned. So that is the main focus of this revision session. So I will not be covering everything. Many of the slides we will be just going through, and with this current assignments, like this year's assignments, I have jotted down numericals from week 5, 6, 7, and whatever numericals I could find from all these assignments that we will be solving together, right? So these are the types of learning analytics, just to set the tone. So you can use this PDF. Again, this PDF I will be sharing for link to everything that one resource link to that spreadsheet where all the session recording, then all the PDFs, everything should be accessible by this Google Sheet, Google Drive link, which I have pinned in the chat box. So that's the master link. I will ask TAs now to share this link with you through forum, because now, yeah, immediately by tomorrow I will ask them to do this. So okay, let's dive into this. We have done, actually we have seen this diagram so many times. We start with description of what the data looks like, what happened exactly. So this is all about learning analytics, different types, and how we can use different analytics techniques to answer which type of questions, right? So what type of question is, as the name suggests, is for descriptive analytics. Then diagnostic, as some diagnosis or why something has happened. So to get answer to that question, we do diagnostic analysis. In descriptive analysis, we generally go for visualization using different graphs, and other things. And in diagnostic analysis, we try to understand why certain things have happened. So for diagnostic analytics, we generally do SPM, DSM, process mining. We try to understand the sequence of actions, and which actions led to which type of learning outcomes. So that type of questions are answered in diagnostic analytics. In predictive analytics, we do regression analysis. We try to, with the help of features or independent variable, we try to compute, or we try to predict the dependent variable. Why we need to predict is so that we can optimize the learning experience or the learning environments through prescriptive analytics. If we are able to predict at-risk students, then teachers, educators, they can take steps to mitigate failures or dropout rates in the course. Yeah? So this was about types of learning analytics. Now this is one of the important points. If you are planning to conduct your own studies, you are planning to carry out your own research, then you have to carefully plan the study, take informed consent from participants, then collect the data, store that data safely, then pre-processing or cleaning of that data, anonymizing of that data. Anonymization is nothing but removing all the information which can lead to, or which can help in identifying our participants, the personal information of our participants. So we will avoid that, or we will remove that, or we will make it, we will mask it. So that entire process is anonymization. Then while storing that data, we have to be careful. We have to do encryption, we have to protect it. We can't put it up on the internet. If we don't have we don't have consent from our participants, then we can't do that. But generally, for study consent, we tell all the participants how we are planning to store that data and for what purpose we are using that data. So if that data will be public, then also we'll have to inform all the participants. Yeah. So that has its own merits and demerits. Then but we have to inform participants about how we are going to process that data. Then once the pre-processing, anonymization, everything is done, then we'll come to feature generation. That is, we will derive or we will compute some useful information based on the raw data. Then we will apply analytics on that data to understand why something has happened or what data looks like, then why something has happened, and using those set of features we'll try to do the predictive analytics also. Yeah. And we'll try to infer all the results to make connection, how we can improve the learning outcome, how we can optimize the learning environment, and so on. So now here was the feature generation step coming. So feature generation has couple of techniques involved. Encoding categorical variable, because computer understands the language of numbers. Computer doesn't understand the natural language or English or any spoken language. So all the categorical data which we have, we need to connect it into numerical form, and that is called encoding. Then we can scale the features, or we can normalize the features, we can group, we can cluster. Then using NLP we can extract some information based on their textual input. So all these techniques come under feature generation. So now we will just zoom into what different techniques of encoding are there. So most popular encoding is one hot encoding and binary encoding. So so both the encoding techniques we will be using to convert the categorical data into numerical format. So categorical data is like our gender, male, female, and so on. So likewise, when we have fixed value, like from the set of values, certain fixed value will be assigned to that particular variable, then that we call as categorical data. So here example is we have color 3 category and 3 values like red, green and blue. So one hot encoding will create, what it will do is I will write it down here. Yeah, what one hot encoding will do is red, green and blue and red. It will create 3 columns like this, because these are 3 possible values. So suppose for example we have 4th value in the data as green, but possibility of this variable is only 3. Either it could be red, or it could be green, or it could be blue. So for red, this value will be 1, this column will be 0, 0. For green, this column will be 0, this will be 1, 0. For blue, this will be 0, 0 and 1. Again green, so red value will be 0, green value will be 1 and blue value will be 0, and so on. This is how we will do encoding for this particular variable, one hot encoding. Now what happens in binary encoding? In binary encoding we assign the number to all these categories, no? So we have 3 categories, red, green and blue. So we will make red as 1, green as 2 and blue as 3, and we will convert those numbers into binary. So that's why it is called binary encoding. So this is theory part, and this was I took this part because it was raised as a difficult topic. But don't worry, there may not be any implementation type of question, but a theory based question only on this topic. So you will not be asked to do one hot encoding for anything or binary encoding for anything, but based on what is the drawback of one hot encoding. So one hot encoding, if you have multiple categories, as many categories, your data will be that much. Like if I have 10 categories with me, then my data will have 10 columns for storing that one information. So that's the major drawback of one hot encoding. And to overcome that drawback, we come up with binary encoding, because in binary encoding there is just one column which will need to be which we need to store this information about red. So value we will be storing is 001. For green, value we will be storing is 010. Blue, value we will be storing is 011. So that is how we are overcoming the drawback of one hot encoding using binary encoding. So next, now we are on to almost week 2 or week 3 maybe. Yeah. So performance metrics of machine learning algorithms. So now you will understand this part better, because now we have seen how the predictive analytics works, how regression works. So now we know that what are predicted value, what is ground truth or true value. So here is the list of formulae for you to refer to. So in order to better memorize or better understand these formulas, I have given a rough definition in easy to understand language. What is accuracy? In simple words, accuracy is what proportion of all the predictions of that algorithm are correct. So that is accuracy, how accurate our predictive algorithm is. So that accuracy, true positive and true negative, are the actual predictions now, which are true value and predicted value are same. So that is true positive, and true value and predicted value negative values were same, that was true negative. So this is how, so these are the, in simple English, what is precision, what is recall, and their formula. Okay, so this you can refer to while revising. So based on all the formulas will be based on this table, yeah, the prediction value table. So this is also called confusion matrix. So based on this confusion matrix, you will be able to calculate accuracy, precision, recall, as well as kappa score and F score. So kappa may this P is probability. What is the probability of um, the observation and expected and so on. So this we have solved, the kappa score questions we have solved during our week 3 assignment session. So for more information, please refer to that week's recording and refer to the PDF where we have solved side by side. I have made all the calculations very clearly written to that particular question. But here I am sharing this for list of formulae. Okay, so I will not be going through how this formula is coming or anything, because that we have already done and you can refer to that also. So today what we will be doing is we will be solving the questions which are there in this year's assignments, which so it will be kind of revision. So this theory information is like before we go to solving the questions, all this information is very useful from revision point of view. Before exam you should have some list of formulas and some information with you which you can quickly refer to. So that's why I'm going through this. Okay. So many of you had raised concern about ROC curve and what is true positive rate and false positive rate and so on. So that's why these slides are here. So as the name suggests, true positive rate is also referred to as sensitivity, and false positive rate is 1 minus specificity. These both the variables when plotted in such graph. So this is sensitivity here and this is 1 minus specificity. So this is called as ROC curve. So this is the formula for true positive rate, and this is the formula for false positive rate. And now coming to ROC curve, when we plot this is our reference line. Yeah? From 0, 0 to 1, 1, this horizontal line is our reference line, which is equivalent to randomly guessing. Because our prediction algorithm, whether it is doing some calculations based on the features which we have generated, the equations which we may have referred to, so based on that it is supposed to predict the values. But what if it is randomly guessing certain values? Then your graph of sensitivity and 1 minus specificity will look like this. This 45-degree line like this. So any curve which is falling below this line like this is bad, and anything going above this line of good, this line of random guess is considered good. Yeah. So you remember we have solved such almost 2 types of questions, one in that week's assignment and one in week 12's assignment. Yeah. So this was about ROC, how to read the graph for ROC curve. Then in last week somebody had asked for box plots. So box plot comes under descriptive analytics. It is used to understand how the data looks or what the data looks like. Yeah. So box plot generally represents the data in quartile, how it is distributed. So along with Shrija, random guess is guessing randomly. You know, the English word random guess. What is when you guess something randomly without doing calculation is random guess. Hmm? So box plot is now it is used to understand how the data points are distributed. So every quartile, like from Q1, from this is minima, this is Q1, Q3, there is median value is Q2, and then this is maximum value. So this formula is for maximum value of the data point and minimum value of the data point, and interquartile range is Q3 minus Q1. Median is the when we arrange our data in ascending order or descending order, the value which comes in the middle is called median. So 25% of the data lies between this minimum value to Q1. That's why the word given here is quartile. Yeah? And next 25% lies between Q1 to median value. Then next 25% lies between median to Q3 value. And the last 25% lies between Q3 to maximum value. And anything which is greater than maximum value is also referred to as outlier, and anything minimum that minimum value is also considered outlier. So how to get this values? Using this formula. Q1 minus 1.5 times IQR is interquartile range. Interquartile range is nothing but where the 50% of the population, what is the range of 50% of the population, from which point to which point the 50% of the population is lying, our data points. So this you can compute using this formula, Q1 minus 1.5 times of IQR, and maximum is Q3 plus, this has to be plus, Q3 plus 1.5 times of IQR. So this formula will give us minimum and maximum value, and anything beyond those value is outlier. These are the values for Pearson's correlation. Correlation is how these variables are correlated, or how they are influencing each other, to find that mathematically there are two types, which is Pearson's correlation and Spearman's correlation. So what Pearson's does is Pearson's considers the continuous data as a continuous variable, and Spearman's rank correlation ranks the data and then compares the rank. Yeah? So that's why Spearman's rank correlation is less sensitive to outliers. Yeah? Because outlier will have it is a rank based system, so the mean value or anything will not be influenced by the rank of outlier, right? But in Pearson's, when we are considering mean value, yeah, so mean value for x and mean value for y, so here outliers can easily influence this Pearson's correlation value. But whereas in Spearman's rank, we are assigning the rank for computing the correlation, so it is less immune to outliers. Will there be numerical problem on this formula? There may be numerical formula, there may not be. I don't know. In exam there may come the numerical formula, but it may be from Pearson's correlation or it may be from Spearman's rank correlation. I'm not sure exactly which question will be asked in the exam, but again I am repeating this same thing, that I am giving you all the formulas together so that it is easy to refer for your studies or revision or whatever. Yeah? So this is the difference between the ranks of dependent variable and independent variable. Here x is independent and dependent variable, x and y. Yeah, it could be anything because we are computing everything same, So this is the mean value for x and mean value for y. For all the data points, we will be computing the difference between them and doing their product, adding that and computing this R value. Similarly, here the row value is 6 times summation of difference between all the ranks, and n is total number of samples or total number of data point. So these are the formulas. This is the difference in ranks, and this is total number of samples. This is so this question may come from how we will decide the number of clusters for k-means clustering. So where the elbow occurs, that gives us, so this is the how we will compute the squared error function or objective error function j, and j will give us the information about what should be the optimum number of what you can say optimum number of clusters. But through this graph where this elbow, that means you notice that from this point number of clusters is 3. From this point the difference between this sum of squared error, it is not decreasing much. But here for cluster 1, cluster number of clusters is 1, number of clusters 2, and number of clusters 3, the squared error, sum of the squared error function, that was decreasing drastically. So this is the optimum number where the elbow occurs. That is how we decide what is the optimum number of or what is the best suited number of clusters, right? So this was about okay, again another doubt was asked about no, I'm not doing extra example or anything. We will, if that comes in the set of examples which I have included, then we will be doing. I think I have couple of, because in your doubts or last week you had asked week 7's questions, so that has these clustering computing centroid and all those things, yeah. So don't worry, we will be doing that. So clustering also, this hierarchical clustering was also one of the muddy point. So there are two types of hierarchical clustering. So these types are nothing but these are the approaches how we will be doing the clustering so one is top to bottom approach and one is top down approach, yeah. So bottom to top approach is Agnes or agglomerative nesting, where initially all the data points are considered as one single cluster. Each data point belongs to one cluster itself, and then based on their distance within each other, distance between the data points, those who are closest, the data points who are closest, they will be merged into one cluster. So if we have 5 data points like this and these are closest, so we will be on first run or the first iteration, we will be merging them, computing new centroid by averaging these two values. So now from these centroid we will compute distance from all the data points. If this is closest to this data point, and now these two can be merged, so we will be doing it till we reach only one big cluster which has all the data points together. So we are going from individual data point to one big cluster is Agnes or agglomerative clustering, and Diana or decisive clustering is exactly opposite of that. Initially we will consider all the data points to be part of one big cluster, and then we will be grouping slowly based on the data points which are closer to each other, and so on. So by the time, and when we will stop is when individual data point is one cluster, exactly opposite of how agglomerative clustering works. Now these are some definitions of S support and I support. But if you have hard time remembering what is it, then again I have included simple what you can say prompt in simple words, that what is sequence support is how many students have that particular sequence or pattern in their log. So how many individuals will have that particular pattern is sequence support, and for each student how many times that particular pattern is occurring is instance support, instance of that pattern, and for how many students that particular sequence occurs is sequence support. So this definition will help you in solving the numericals also. If there are any questions, like they give you sequence support value and they ask how many students have it. So sequence support multiplied by total number of students will tell you how many students have that particular pattern. And so on, so these questions will be important to remember, like how to differentiate S support and instance support, I frequency. So instance support is also called as I frequency. Yeah. So as the name suggests, frequency will tell us how many times that particular pattern is occurring for that each student. So what is the frequency of that pattern is instance frequency. Okay. Now coming to numericals from this year's assignment. So these are all numericals which you have solved for your assignment submissions. Right, so this we will be solving because that was suggestion by most of you. So mostly suggestions were for week 7, but I anyways thought that we will solve all the week's questions. Yeah. So this was week 5's numerical. We are given attendance values and marks values, and we are supposed to find the Pearson's correlation. Yeah. So I will not be solving this, you will be solving, but I will be telling you how to solve. So this is, let us assume this is our variable x and this is our variable y. So first step will be computing mean of x and mean of y. Yeah. So can you quickly compute the mean and tell me what are the values of mean x and mean y? All these value add and divide by 5 because total n, our number of samples, is 5. So add and divide by 5 and then tell me the value, what is the mean attendance and mean marks value. Yeah, 78 for attendance and 79.6, right? Yeah. So now what we will do is we will do another computation of x minus x bar and y minus y bar. So we have x bar value, we have y bar value, so we need to populate x minus x bar and y minus y bar for all these 5 values. 12, 75, it will be minus 3, 75 minus 78, so 16, 18, 7. So this was x minus x bar value, okay, and y minus y bar similarly. So we will compute all these values y minus y bar on this table over here. So formula, if you look at, it is asking for x minus x bar whole square also. Yeah. So here is the Pearson's correlation formula, x minus x bar, y minus y bar's product also, and their square and sum of their squares, these values. So x minus x bar is very crucial. So that value x minus x bar and y minus y bar we have to compute, and then we have to compute their product and their squares individually, right? So this was the step 1 of computing average x and y. This is step 2, computing of differences. Now coming to step 3, what we will do, let us call this as A and this column as B. So A multiplied by B, product of A and B, that we have to compute, and A square and B square, we have to compute this. So once we have computed this value, multiplication of x minus x bar and y minus y bar, this multiplication will give us the formula value in denominator. So this is all simple calculation which you have to do. That's why I'm not finding out the numbers here. I'm just telling you the steps. You guys can do it. So now formula says, we are calling this A and B. Okay, so summation of AB, multiplication of here, multiplication their value, and then summation, divided by sum of A square, sum of B square. So this is the formula. So once you have this, you find out their summations also. So this will give you summation AB, this will give you summation A square, this will give you summation B square, and then from this would be your step 3. This would be your final step, substituting these calculations here. It is just repeated calculations. You have to subtract everything from the mean, then square it, then do the product, and so on. So once you do this, you will get some number which should be within these options. So this is how any correlation question, if correlation question comes, this is how you are supposed to do it. So correlation is, you have to do some numerical calculations repeatedly, n number of times. So it starts with computing the average value, then subtracting these values from each data point, then square it and product it, then product of square also, product of difference also, difference between data points and mean, and product of this square of these difference also, and then substitute it in the formula. Okay, so Ria has got an answer of 0.912. So that was our final final answer. It is not in the option. We'll go with the closest to 0.91 seems to be this 0.88, because 0.96 is 0.05 away, but 0.98 is 0.03 away. So this would be closest. This could be the answer. I'm not sure if this is wrong or right. If this question is disputed, I'm not aware of it. But yeah, this is how you do the calculations. Okay, so I'm moving to next question. So question 9 is, consider following sequence of actions. They have given the sequence of action. Now what is the probability of transition from A to C? So what is the total number of transition from A to X? X is any state. So we will count how many times A has occurred. So A is 1, 2, 3, 4 and 5. So 5 times A's transition to any has occurred. Yeah, so A to X is 5 times. Now how many times A to C has occurred? So let me change the color. A to C. A to C this once and twice. Yeah. So A to C has occurred twice. So probability of A to C is 2 divided by 5. So decimal value, till where we have to take decimal value, 2 or 3 places, depends on formula. You look at the formula, they have done it till 3 places, because this is MCQ type of exam. So you don't have to do all the steps and then you will get awarded for the steps you are doing. It is not like that. You have to get to the final answer and then match the options. Right. So you look at the options and then take a call whether you want to go for 2 decimal points or 3 decimal points. Similar to correlation, this transition, no, this is probability, not correlation, Riya. this particular question is of probability. So what is definition of probability is you will count how many times this has occurred, and that divided by total number of what are the possibilities of total transitions. So this is the possibility of total transition A to any state. So how we are just counting A to B, A to B, A to C, A to C, A to B, and A to C. So 1, 2, 3, 4, and 5. So A to any has occurred 5 times. Now out of these 5 times, how many times the state was transitioned to C? 2 times. So that's why the answer becomes 2, 5. Actually there was a topic after significance, transition, and correlation. Okay, yeah, fine. It is not similar to correlation. This is different part. This is about state transition diagram, or which is roughly leading to our process modeling also. The process model may how significance and transition and correlation works. It is about that, and not that correlation. This correlation is different. This is correlation between different transitions, the states, how from one state we are going to other state, and that correlation was correlation between the variables, independent and dependent variable. Okay, so even though the word correlation remains the same, but the context is different. Now next question is they have given the values for some pattern, that I frequency mean value is 6, I frequency standard deviation is 7.5, S support is 0.6, and N is total number of samples. Total number of samples are 10. Then how many students have performed that action? So I have told you S support tells us how many number of students, how many students from our samples have that particular pattern. And I frequency is how many times that pattern has occurred for each student. Ria, I will ask you to hold on till we reach to the end of this session to ask the question, because I think I have included this question because this is from current this year's numerical, right? So if by the end of the session your doubt is not covered, then at the end you put these questions in chat box, then we will try to solve them. Okay, but for now this is request to everybody that hold on to the questions which you want to ask, because we may end up solving them in the session. Yeah, so let's save some time and energy for everyone. If those questions are not solved in this session, then at the end please type it in the chat box so that we can solve it together. Number of time pattern is occurring for each student. Yeah, so by this definition we know that S support value will give us details about how many students will have that action performed. Yeah, so this is 0.6 multiplied by 10, which is 6. So this is the answer. So I'll request everybody, when we are solving a particular question, let the chat be related to that question only. Otherwise, I will get confused at what Ria is talking about or what Arnav is replying about. Yeah, so I got confused while solving that, okay, this is not 0.75 students did not perform this action, okay, 6 students performed this action. So that's why, because we have a lot to do and we have less time, we have so many things to cover. So that's why today's session, please abide by the this thing, because if I lose the tempo, then I may not share important pointers with you all, okay, even though I would love to share everything. So Ria, I think this is this the question which you are asking? No, significance, you are asking for correlation. Fine, if we don't get it, we'll come to that at the end, okay. So now this is about significance of action. again this sequence is given, and we are asked to get the significance of action A. Yeah, so we will see how many total actions are occurring in the sequence. Only A and B, two actions. Yeah, so A and B, we will count. So these type of questions are nothing but you have to count how many times A has occurred and how many times B has occurred. So we'll count how many times A has occurred: 1 2 3 4 and 5. How many times B has occurred? 1 2 3 4 5 6 7. 7. So for significance or anything, we do everything which is relative to each other. Yeah, so B has the highest count, more number of times the action B is occurring, so the significance will be correlated to B. So B's significance will be how many times B has occurred divided by maximum number of times, 7. So significance of B is 1. Now A's significance would be 5 divided by 7, like maximum was 7 count and out 5 was A's count. So 5 by 7, so 5 by 7 would be around, I think 0.71, I think. Yeah, so this would be 0.71. So this is the action, and B's significance will be 1. Yeah, so this was significance, and this is correlation question which you guys were asking, so we are solving this. Okay, so again for correlation we are supposed to get it for the sequence of action from A to B. So the pattern given to us is from A to B. So what we will do is we will compute how many times A to X or A to any transition has occurred. So let us count how many times A to A has occurred. One, two, A to A, na? AB is 1, AA is 2, then AB is 3, then AB 4. So 1, 2, 3 and 4. So this is 4 times. Yeah, so this is 4 times. We are not counting this because it is not transitioning to next. It is ending here. It is stopping here. Yeah, so that's why we are not counting this A as one transition. A to any transition, we are not considering this, but we are considering A to B, A to A to B and A to B. So 4 number of times, and how many times transition A to B has occurred. So let us check once. This is 1 and this is 2. 1, 2 and this is third AB. So 3. So now we'll come to the correlation part, that out of 4 transition of A to any, 3 times it has transitioned to state B. So A and B, what is the correlation between state A and state B is 3 divided by 4, which is 0.75. So this is the answer, 0.75. So Shrija, I told you last week also, I will be showing it at the end. Let's not break the flow. We have a lot to discuss. We will go through it again. But when I am on that particular slide, please make sure to pay attention to this question. And whatever you are missing, please ask me to show that at the end, so that you are with the flow. Otherwise, you will get stuck in the previous slide all through the end of the today's presentation. Right, so please note down what question you want. We'll come back to it at the end, and be with the current slide. Pay attention to what I am doing now, how I am doing now. Otherwise you will end up missing what we are doing currently, and you will always be going to previous thing. No, it is kind of similar because the correlation definition remains the same. that how one value is influencing other value. So here what we did was we calculated the probability of transition of state from state A to state B. So here correlation is nothing but probability of that transition. How many times A will be transitioning to B is correlation between A and B. And for this thing, what you can say, for correlation between independent and dependent variable, it is not about probability. It is about how the degree of influence, or to what extent that particular independent variable is able to determine the value of dependent variable. So these concepts are different. Even though the name is similar, the concepts are different. So don't hang up on it so much that you will get entangled in it, come out of it. This is probability, this correlation is probability, and that correlation is not probability. Okay, so moving on to next question. This was most widely requested question from week 7, question 4. So data points are given to us, and clusters, initial cluster centers are also given to us, and we are supposed to compute how it will be distributed, how these points will be distributed to cluster 1 and cluster 2 after one iteration. Yeah. So for this also I will request you, because here are also simple addition subtraction type of calculations, but these are repetitive calculations. So that's why, just like for Pearson's correlation, we followed a tabular calculation form. For this also I would suggest please follow the tabular calculation form. So how we will do this is, how I do, let me tell you. So what I do is I generally write down all the points one below the other, 2, 3. So this is first column of my table, the data points which we have, and 9, 10. Yeah, so all 5 data points I have written. Now this is cluster center 1 and cluster center 2, C2. So center 1's value is 2, 3 and center 2's value is 8, 8. So what I will be doing is computing distance between them. X coordinate of centroid C1 minus x coordinate of the point. Y coordinate of centroid minus y coordinate of the point. And adding their square will give us the distance, the simple distance on the graph paper. This is the distance formula. Addition. So this is the distance formula. This may or may not be given to you, but this we have done in our high school, so it's not very difficult to remember. Yeah. But now here we are supposed to compare which points are far and which points are near. So for that, to avoid one calculation, what I do generally is I don't consider the square root. If square is higher, then square root will also be higher, right? So that's why I don't consider this square root option, and I will compute only this, and I will not take the square root. Okay. So now coming to how to populate this. 2 minus 2 0, 3 minus 3 0. So this is distance between this point and centroid is 0. So now coming to this, 2 minus 3 1, so 1 square plus 3 minus 3 0, 0 square, so this is 1. 2 minus 6 4, 4 square plus 5 minus 3 2 square, so 16 minus 4 20. 2 minus 8 6 square, 3 minus 8 5 square, 8 square plus 7 square, so 36 plus 25, 61, 64 plus 49, wait, calculation mistake, this is 7 square plus 7 square, so 49 plus 49, 98. Yeah. So now similarly what we will do is here 2 minus 8 minus 2, 6, 5 square, then 5 square plus 5 square, then 6, 2 square plus 3 square, 8, 8, 0, 1 plus 2. So 6 square plus 5 square is 61, 25, 25, 50, sorry, 25, 25, 50, 4 and 9 is 13, 0 and 5. Yeah, so this is the distance. So okay, so now 0, between 0 and 61, 0 is lesser. Between 1 and 50, 1 is lesser. Between 20 and 13, 13 is lesser. 61 and 0, 0 is lesser or nearer. 98 and 5, 5 is near. So that means these points will be assigned to C2 and these 2 points will be assigned to C1. So that brings us to option 2. Yeah, so now these 2 points are in one cluster and these 3 points are in one cluster. Even though we are done here, I'm going one step ahead and telling you how to compute centroid for next iteration. For second iteration, what is the new centroid which you will be considering? So since these 2 points are in one centroid, we will average the x coordinate and y coordinate of these 2 points. So 2 plus 3 divided by 2 and 3 plus 3 divided by 2, which will be 5 by 2, 2.5, comma 3 is new C1. And new C2, there are 3 points. So we have to consider all the 3 points. So 6 plus 8 plus 9 divided by 3, comma 5 plus 8 plus 9 divided by 3, which will be 23 divided by 3 and 10. 5, 8, 10. Again 23 divided by 3. Yeah, which will be 23 divided by 3, 7.2, 6, 7.666. Yeah. So this is the new centroid for second cluster. So for computing centroid, you average all the points which belong to that particular cluster. Here there were just 2 points, so we divided it by 2. Here there are 3 points, so we divided it by 3. Very simple logic. Okay, can I move ahead? Okay, great. So let's move on to next question. You have following points 1, 1, 2, 2, 4, 4 and 5, 5. If the initial clusters are 1, 1 and 5, 5, what will be the cluster centers after first iteration? Okay, great. So the thing which we did for previous problem, same thing we have to do it now. Yes, we have to do it again and again for getting to elbow points. Yes. Yeah. So we will do it again. We will make a table. Let us write down all the points here and center 1 is 1 comma 1 and centroid 2 is 5 comma 5. Yeah. So distance is 0, 1 plus 1 will be 2. Difference is 1 minus 4 3, 3 square 9, 18, 4 square plus 4 square 16, 16, 32. Now here 4 4. Yeah. So 4 square plus 4 square 32. Then 3 3, 3 square plus 3 square 18, 9 9. Now 1 square plus 1 square 2 and 0. Yeah. So this is, so now we have to find out minimum distance of each point from which centroid. Yeah. So 32, and between 32 and 4 this is less, between 18 and 2 this is less, 18 and 2 this 2 is less, 32 and 0 this is less. So these 2 points will be assigned to centroid 2 and these 2 points will be assigned to centroid 1. So now in order to compute new centroids, C1 is 1 plus 2 divided by 2 because there are 2 points, and C2 will be 4 plus 5 divided by 2. This is 1.5 comma 1.5 and this is 4.5 comma 4.5. Option 1 is the answer. Yes, you can plot the points graphically to get the clusters also, but then you will have to be careful. This addition subtraction is easy, no? You just have to difference and then square. But whatever suits you, whatever method suits you, you can do that. Centroid part of question 6. We haven't done question 6 yet. We are still on question 5 only. Week 7 question 5. We are still here. Okay, can I move to next question? So we are now on question 6. So Shrija, pay attention. We are now on question 6. So we have 6 data points and you are using k-means clustering with k is equal to 3. That means number of clusters are equal to 3. And they are given initial centroids. So after first iteration, what is the within cluster sum of squares? So this question we will again make a table. So let me just see the data points. So let's take this black color. We will write down the data points first. 1 comma 2, 2 comma 1, 4 comma 5, 5 comma 4, 8 comma 9 and 9 comma 8. So centroid 1, centroid 2 is 4 comma 5 and centroid 3 is 9 comma 8. So now what we will quickly compute the distance like this here. Difference and square and add there and there itself. So here difference is 0. 1 minus 1 0, 2 minus 2 0. Here difference is 1 square plus 1 square. Difference is 3 square plus 3 square 9 9 18. 4 square plus 2 square 16 plus 4 20. 7 square plus 7 square 49 49 98. 8 square plus 6 square 36 and 64. 100. Now we will again compute the distance between centroid 2 and all points. So 3 square plus 3 square, 18. 2 square plus 4 square, 20. 0, 4 comma 5, 4 comma 5. 1 square plus 1 square, which is 2. 4. 4 square plus 4 square, which is 32. 5 square plus 3 square, 25 plus 9, 34. Now 9 comma 8, and we will compute the difference between the each point and this centroid. Okay? So this is 8 square plus 6 square. Yeah, wait, computer, 100. Then 7 square plus 7 square, which is 98. 5 and 3. 5 square plus 3 square is 34. 1, 1, 2 and 0. Yeah? So now shortest distance from which centroid? C1, because 18, 100 and 0. 0 is smallest. So this point belongs to C1 here, C1. 2, 20 and 98. 2 is smallest. So this point also belongs to C1. 18, 0 and 30. Did I miss any point here? I think I missed some point. Yeah, this 5, 4, which is 4 square, 32. Yeah. Okay. Yeah. Now we are okay with total n. Now between 18, 0 and 34, 0 is shortest. So this goes for C2. 2, 20 and 34. 32. 2 is shortest. So these two belong to C2. Similarly, here 2 and 0, these are the shortest distances. So these 2 points belong to cluster 3 or C3. So now what we are asked is, what is the sum of total within cluster sum of square? So total within cluster sum of square is asked. So for C1, what is the within cluster sum of squares? This is sum of squares, right? This is sum of square. What we are doing is we are computing sum of squares. So within cluster, these two belong to one cluster. Within cluster sum of square is 0 plus 2, 2. For C1, it is 0 plus 2, which is 2. For C2, these 2 points belong to C2, right? For C2, 0 plus 2, 2. For C3, 0 plus 2, 2. But we are asked total within cluster sum of square. So total within cluster sum of square is, we will add this 2 with this 2 and this 2, which comes to 6. So after first iteration, we actually kind of separated all the points and assigned cluster to them, and then computed their within cluster sum of squares. For each cluster we computed sum of squares, and then we added that sum of squares together to get within cluster sum of squares. 6 is not part of option. I think this question, there must be some typo or some error, but this is the final answer.
Hello.
Yeah, yes, Riya. Yeah.
Ma'am, what we'll do if in final exam there was a error in question?
Then you all will get marks for that. That's the NPTEL
Okay.
policy. If the question, some typo, because what happens is these questions get manually entered in the portal. So sometimes while manually entering the options, the numbers, some typo is bound to happen. So if such error happens in the final exam, then that question is given correct for everybody. So don't worry about the typo or not correct option not being there in the options. So in that case, you all will get marks. Can we move on to next question? This is clear for everyone now, how to compute within cluster sum of squares. So this is how we are doing it. So this is within cluster sum of squares. Why do 3 into 6? Pravida, can you unmute and yeah, but for each cluster we anyways did it individually, no? And then we are computing. So for cluster 1 sum of squares was 2, cluster 2 sum of square was 2, cluster 3 sum of within cluster sum of squares was 2, and I added and got 6. So am I doing something wrong? Like maybe I may be wrong, but this is how I do it.
Okay, I thought that because there are 3 clusters, no? So will be 3 into.
Okay, but haven't we computed for individual cluster what is the sum of squares?
Yes, we are
Yeah,
done. Yes.
yeah. So I think it's not 18, but it's 6. I mean, do you agree or?
Okay. Okay, ma'am.
I mean, I'm not convinced for 18 as answer because we are already done it for 3 clusters. So why do it? Why multiplied by 3? Shrija, I did not understand your question only. Explain cluster parts of sum of squares. I didn't understand what is cluster part. Which part you are referring to? Out of these calculations, we just simply computed which point goes to which cluster, and then for each cluster there were 2 points assigned, and we just added the distance between that point and the cluster center. That gave us sum of squares for clusters, and that each sum of square added to get the total, which we got as 6. Yeah, yes, Ria.
Ma'am, if we had 3 points in one cluster, then we have to calculate the 3 distance, right?
Yes. So now see, every cluster has 2 points, but say for example, what we can say. Okay, so this 32 is suppose 1. Yeah. So this also, this point 5 comma 4 also comes to C3. So in that case, here the sum of this distance between the centroid and the data point is 1. So for C3, the sum of squares would be 1 plus 2 plus 0, 3, which is 3. This for centroid 2 it would be 0, for centroid 1 it will be 2. Then sum of squares, the total sum of squares would be 2 plus 0 plus 3, 5. Yeah, so we have to compute for see, for one cluster if we are assigning 3 points, then we have to compute distance from all those 3 points to centroid and then add it to get the within cluster sum of squares. Yeah, yes, Rija, please unmute and ask so that I'll be able to address it better. You're not at all audible. I can see that you have unmuted, but absolutely nothing is audible. If anyone else is able to hear her, please try to convey that message to me. Shrija, can you mute and unmute again? You're still not audible. I'm not able to hear. No, still not audible. I didn't understand. I mean, I didn't hear anything. Understand is your next step. I'll give you some time to type in the chat box, because since your doubt is related to this question, let's dwell on this slide for some time till Shrija asks what she wanted to ask. Shrija, if you're typing anything in the chat box, please lower your hand so that I can wait for you, otherwise I'll move. Should we move on to next slide? Yeah, you're typing. Okay, I'll wait. Are you in the meeting or you left? I'm not able to understand. You are in the meeting. Okay. Okay. Let's give couple of more minutes to her to ask question. Meanwhile, if when she is asking, I'll just repeat the process, because there seems to be a bit of confusion about how these clustering questions are to be solved. So what we do is we assign the data points which are closest or nearest to centroid. So we are supposed to find the distance between the data point and the centroid. So in this table we are doing that only. We are finding the distance between the centroid and the data point. So we had 3 centers and we computed distance of each data point. So these are the data points. So each of the data point, so we are computing distance between each of the data point and the cluster center. So this is what we have done in this table. Distance of 1, 2 from 1, 2 is 0. 1, 2 from 4, 5 is 3 square plus 3 square. So this is how we populated this entire table. So now coming to next step, how to decide or how to assign the clusters. So cluster assignment happens based on the nearest centroid. Okay, so for these 2 data points, nearest centroid was C1, because distance, the sum of square is 2 and 0. Here it is 18, 20, 198. So obviously these centroids are very far from 1, 2 and 2, 1. So these points will get assigned to centroid 1 or cluster 1. And similarly, the shortest distance from each of the centroid is there. So C2 is shortest distance. So these 2 points get assigned to C2. And for last 2 points, the shortest distance is for C3. So these 2 points get assigned to C3. This is how we are assigning these data points to centroid. So now we have 3 clusters and we know which data points belong to which cluster center or which centroid. So for within cluster sum of square, we are supposed to compute distance between the data point and the centroid to which that particular data point belongs to. So this is for these 2 data points, this is the sum of squares within cluster distance. Within cluster, we are not going outside cluster. We are staying very much within cluster. For cluster 1, these 2 are data points 1, 2 and 2, 1. Centroid is 1, 2. So that's why within cluster sum of squares is this 0 plus 2, which is 2. Similarly, for cluster 2, these are the 2 data points 4, 5 and 5, 4. And this is the centroid 4, 5. So within cluster, sum of square is 0 and 2 for these two data points respectively. So we will be adding that, getting 2 for centroid 2. Similarly for centroid 3, these two data points with centroid 9, 8, sum of square is 1 plus 1 which is 2, 1 square plus 1 square which is 2, and 0, 9, 8, 9, 8 distance is 0. So again for cluster 3, within cluster sum of square are 0 plus 2 which is 2. So now total within cluster sum of square we are computing is 2 plus 2 plus 2 which is 6. I already repeated entire process, Rija, so I hope your question is answered, because I actually told how we are deciding which cluster which point belongs to, depending on the minimum cluster. So this is not just for calculation of within cluster sum of square, but this is for calculation of computing new centroid, assigning to new clusters. So this calculation remains the same. For within cluster sum of squares, we are just considering this sum of square distance. We are just adding it together for each cluster. This is what I have done, very step by step. Every step I have mentioned in detail, how we computed. So it should be very clear from this table how we are computing this sum of squares and how we are assigning these clusters. Every step I have color coded. So even after this you are not understanding this, then I will suggest, please go to the recording again, see the lectures again from the portal, go to our session recording again, because this we have done during that week also, week 7 also, our week 7 last year's example. So there will be different example, go through that. If still you are not able to understand, look for other resources on the internet. I'm moving on to next question now, okay? So week 7 question 9, we are given some data points 1, 2, 2, 3, 5, 8 and 8, 8. So we have this 4 data points with us, and the question is, using single linkage nearest neighbor agglomerative hierarchical clustering. So this is just the long name which they have given, okay, but the clue lies in agglomerative hierarchical clustering. What agglomerative hierarchical clustering suggests is, we are considering all the 4 data points as individual cluster, and then we are computing distance between them and merging nearest 2. So now for this, what we are doing is, we will again make a distance table. One, 2, 2, 3, 5, 6 and 8, 8. For this, the cluster center is also, these points only are cluster centers, because it is agglomerative hierarchical clustering. It starts from bottom, goes up, every data point is individual cluster. So if every data point is individual cluster, the centroid is data point itself. So these are the 4 cluster center for us, and now we are supposed to see which 2 clusters have minimum distance. That will be merged, because we are using nearest neighbor to merge. So nearest neighbor is the clusters which have minimum distance. So again we will follow the same process. So now distance between 1, 2 and 1, 2 is 0. Now distance between 2, 3 and 1, 2 is 1 square plus 1 square, which is 2. Now here distance is increasing, right? 4 square plus 4 square, 32. Now 7 square plus 6 square. Yeah. Now here distance between 2, 3 and 2, 3 is 0. distance between 5 comma 8 and 2 comma 3 is 3 square plus 3 square, 18. Yeah, here distance is 0. Between 5 comma 8 and 5 comma 8 distance is 0. Now coming to distance between 8 comma 8 and 2 comma 3, 6 square plus 5 square, here it is 3 square plus 2 square and 0. So now out of all these values, 3 square plus 2 square is 9 plus 4, 13. This is 36 plus 25, 36 plus 25, 61. 49 plus 36, 49 plus 36 is 85. Yeah, so which is having single linkage. Single linkage is only two clusters will be linked at one go. So single linkage, that means we have to consider only two clusters which can be merged together. So what is the minimum distance here? This is 0 0 0, because yeah, from this point this is 32, 85, 18, 61 and 13 and 2. Which is lowest out of this? This 2. That means this particular point can be merged with this cluster center. So these 2 points will be merged and new cluster center or new centroid will be computed for this. How we will compute new centroid? 2 plus 1 divided by 2, which is 3 divided by 2, comma 2 plus 3 divided by 2, which is 5 divided by 2, 1.5 comma 2.5 is new cluster. But now question asked is what is the distance between first two clusters which will be merged. They have not asked us new centroid. I calculated new centroid with the flow, but this is not they have asked. They have asked what is the distance between the clusters which are getting merged. So this is the distance. Here we have computed, right? But this is sum of square. Distance is square root of x1 minus x2 square, y1 minus y2 square. Now we have this x1 minus x2 square is 1 square and y1 minus y2 square is 1 square. So square root of 2. What is the value of square root of 2? 1.41. Brings us to option 2. Understood? Got it? Yeah, I'll move on to next question. So next question, it is asked, you are given 5 data points, again 1 comma 1, 2 comma 1, 4 comma 3, 5 comma 4, 9.8. I think the same data points that we had somewhere up. Okay, after performing agglomerative hierarchical clustering using average linkage, another fancy name, we will not delve too much onto that name and read. The first 2 points to be merged are 1 comma 2 and 2 comma 1. Now what is the new cluster center? Now I will wait for answers from you for this particular question. They have given the points which are to be merged into new cluster. So how we will compute the centroid? Yes, I am getting correct answers, so that means everybody has understood how to do it. 1 comma 1 divided by 2, which is 1.5 comma 1. Option 1. Yeah. So this was the last numerical which we solved from week 7. After that, week 8, 9, 10 didn't have any numerical. I think there was one question about Bayesian probability. I don't know, I think I missed solving that, or I forgot to, or by mistake I removed that question. I'm not remembering. Let us go back. Yeah, I think by mistake I deleted that slide, but I remember what the question was looking like. ठीक है. Oh, looks like I removed everything from this. ठीक है. Doesn't matter. This has a lot of free space. So entropy and information gain wala example wasn't there in the this year's assignment. And one more important tip which I would like to give you is, I'll mention it here also in one of the slides. जगह है कहीं पे, wait, let us, yeah, I'll use this. So there was couple of weeks ago, there was a live session. Yeah, so please watch it on YouTube. So include this is in your to-do list. You will get a lot of important pointers for your exam. Many of the questions are solved there in that session. Those questions are very important from exam point of view. So please make sure that you watch these recording of this live session, which is shared, I think, on which must be shared on Swayam platform, because generally this was the live last live session by instructor. So generally in the last live session, all the exam related questions are solved and exam related tips are given. Yeah, so this is it about entropy and information gain, because it has a lot of calculation to base different bases, no, base to 2, base to 3, base to 4, depending on how many clusters we are forming. So it was decided that not to include questions on entropy and information gain in the final exam 3 years back, when I was TA of the course, where I was handling the discussion forum and setting the question paper and everything. So at that time it was discussed that entropy and information gain questions will not be asked in the exam, because it has different the calculations are more rigorous for this, and it may take a lot of time. So I don't want to take up, intentionally I did not include entropy and information gain in today's session. Yeah, so because it causes a lot of confusion in that week also when we did entropy and information gain. So there was a lot of confusion that time also, and it generally so we avoid asking entropy and information gain question in the final exam. Yeah, so don't worry about entropy and information gain, but still if you want to understand, I will again request you to go back to recording of that week. I have shared the Excel sheet in the chat box, pinned message. So go to that, save that link with you. That link has a lot of live session, all the 12 weeks live session recording access, and all the PDFs access, everything is there shared in that Excel sheet. So save that link somewhere with you. If in today's session many of the problems are not solved, you can go to that particular week's live session recording and see how that is solved. Okay, we'll go back to that. I mean, yeah, you can go back to that whenever you get time. Okay, different size of words, then how to get minimum edit distance? Very good question. So what happens when so for edit distance, what are the uh, edit actions? Yeah, so this was the question in the assignment also, that what are the edit actions. So edit action is substitution, deletion, right? Substitution, deletion, and there was one other thing which I'm forgetting. There were three actions which are edit actions, like substitute, delete, and insert. Yeah, insert. So we will actually count how many of these activities we are performing. So different word size is different, that means we are deleting. So deleting one letter will be one edit distance, one distance. Substitution, substituting one letter with other letter is one edit distance, and inserting new letters is one edit distance. So when you have different size, when you are changing the size of the words, so at that time edit distance will be how many substitutions you are doing, how many deletions you are doing, and how many insertions you are doing. So you will count all these three actions, how many times you are performing. Yeah? So that will give you minimum edit distance. If there are different sizes, the word size is different. So you will have to count how many times substitution you are doing, how many times deletion you are doing, and how many times you are inserting new letters. Okay, any more questions? Okay, Shrija wanted to see some slide, some question. So I'm going through everything. Which question was it? I don't remember. I think it was this question. I'm just keeping it for Shrija's benefit. Shrija, is this the question you wanted to see? React to this message by thumbs up or something, and I am taking up. Yeah, okay, so you go through this, and meanwhile I'm taking up Ria's doubt, how to minimum distance between evaluate and evacuate, I think, elevate. Okay, evaluate and elevate. Okay, so sorry, yeah, so these three letters are same, yeah, and this is same. So we are doing 4 insertion substitution to change evaluate to elevate, right? Oh, my bad. Yeah. So 1, 2, 3 and 1 deletion, 3 substitution and 1 deletion. So minimum edit distance is 1, 2, 3 and 4. Yeah. So for Shrija, I will repeat this particular question. So we are computing probability of transition from A to C. So probability, how we will compute is how many times A to C transition has occurred, and how many times A to any state transition has occurred. So we counted how many times A to any state, A to X, A to any state, which is 1, 2, 3, 4, 5. This is 5. And how many times A to C? A to C has occurred 1 and 2. 2. So this probability is 2 by 5. Very simple. How many times A to any state has occurred? 5 times. You have to count how many times A to any state transition is occurring. Yeah, so that is occurring 5 times. A to C, out of that 2 times A to C has occurred, so the probability is 2 by 5. So all these probability type questions are mostly counting. You have to count how many times it has occurred, what is, how many times total has occurred, A to any state, how many times A to C has occurred. So this is important note, please. If you did not attend last live session by instructor, please attend live session. Please watch the live session recording. Please repeat the transition of A to B. Not understanding, Shrija, your doubt. I'll go through the questions. You let me know which question you want. This is A to C. What is A to B? Repeat A to B. I'm not understanding. What is A to B? Repeat. This is not A to B. Repeat. This is significance of action A. Okay, this question you want. A to B. You can give thumbs up reaction if is this the question you want me to repeat. Okay. So this was the sequence given. Now what we are supposed to find the correlation. So correlation is also very same. Correlation is exactly what is the probability that A and B are occurring together, like A and B, this sequence, this pattern is occurring. So we have to find probability of that. So how we will find the probability of that is very similar way. A to any, count how many times A to any has occurred. So A to any, 1, A second, A to A. Yeah. So A to B, how many times A to B has occurred? 1, 2, 3. 3 times. A to A, how many times it has occurred? 1 time. This A we are not computing, okay? This A we are not considering, because there is nothing, there is nothing after that A, that is the end state. So that's why we are not considering that. So AA has occurred 1 time. So total A to any has occurred 4 times, 1 plus 3. So out of this 4, 3 transition were to B. So correlation between state A and state B is how many times AB has occurred. Out of this 4 is 3 times. That's why it is 0.75. Yeah? ठीक है. Week 7 question 6. This was week 7 question 6, right? K-means clustering. Week 9. Okay. Can you copy paste quickly the question in the chat box? So for naive Bayes classifier, no, mostly the questions are of similar nature. So that we have actually done 2-3 different types of question in our session also. So for naive Bayes, you can go and watch week 9's recording or week 9's PDF. Go through that. You will find some hint there. No. So, okay, yeah. For this was the data which you had given. Yes and no. How many questions? So I'm going to write it somewhere so that. So these naive Bayes classifier, the biggest hint I can give is to come up with the table where you write down how many. Uh, yeah, there is this place. Yeah, what is the number occurring in that, so this is very simply put: 41 to 60, 61 to 70, 2 3 2 1. This is yes, this is no, right? And 71 to 81 0, and this is total. This total is 5, this total is 1, total is 9. But mostly we will not be needing this total. Yeah. So this is what we have, and we are asked what is the probability of the student with 41 to 60 attendance and passing. So let us break down the question. How many students have attendance between 41 to 60%? So how we compute probability is we try to understand what is our total number in that particular thing, and then out of that sample, what is the total sample for that condition, and out of that sample how many students are satisfying this condition which is asked here, passing. So first condition is how many students have attendance between 48 to 60%. How many students have attendance between 48 to 60? 5 students. Now out of these 5s, how many students are going to pass the exam? Passing, yes. So is this the correct answer, 2,5? So for naive Bayes, so I also, one of the reasons of not taking naive Bayes questions in today's session was, if you have this table, you just have to interpret the question. Don't go into formula, that conditional probability formula, that this formula, probability of B given A is probability of A, probability of A given B multiplied by probability of A divided by probability of B. So this formula is very confusing. Don't go there. You may confuse between this, probability of A given B. So best way is to interpret the question and get to the numbers from this table. That's the easiest way to do these type of questions, naive Bayes classifier questions. Interpret the English of the question and then try to answer. So here they had asked the condition. The first condition was attendance between 41 to 60. So take the first condition, attendance 41 to 60. So that will give us the total sample size, which we got here as 50. 5, not 50, 5. And out of these, how many students are passing the exam? 2 students. So probability is 2.5. Yeah, so this one biggest hint I can give for naive Bayes is, don't go for the formula application, interpret the question and then compute the probability using how we usually compute probability. I'm sharing my email ID here. You can find my email ID in the all the PDFs also. Yeah. So if you want to discuss some doubts later, please mail it to me. I'll try to, as and when I get time, I'll try to answer your emails. What is the exam date which you have gotten? Okay, 2nd November. Oh wow, Diwali. Okay, okay, okay. The very next day of Diwali. Good. All the best for exams. And don't worry, all the questions will be of simple nature. It will not be very complicated. We have done enough practice. If you want to revise, you can quickly go through the PDFs which for every week, which are generally with annotations how we are solving the step by step guide. Everything is there in the PDF. If you don't get time to go through all the recordings of all the live sessions, you can go through PDFs. I have tried to summarize the theory part before each week. So initial slides are the theory part covered in that particular week, and later on the 10 assignment questions follow. So please make use of those as a resource for your preparation. This also I will be immediately updating in the folder. So this PDF access you will have right after our session gets over, and recording also will be shared. 9 assignment out of 12. These rules are generally all over same for all NPTEL courses. So you have better knowledge about these compared to me. Many others in this meeting will be able to help you, that you have attempted 9 assignments out of 12. Can best 8 will be considered. Okay, so you will get certificate. Yeah, your query is answered here. So you can appear for exam and you will get passing certificate. Yeah. Admit card, I think there is some download option from your login, no? Again, this question others can answer, how to get the admit card. Either you will get an email notification also about this from NPTEL. Yeah, they'll send an email and it will be in the attachment, and there will be provision to download it from there. Okay, if there is no link, then mail them again and let them know that link was missing so that they can send you the link. They generally reply very quickly about such queries. Yeah, so link has been shared. Please go through this link and check if there is provision for downloading based on your registered email ID or other information. Okay? So today this session has worked as a forum, as a community also, where you are solving each other's queries, helping each other out. So that's a good part. Yeah, happy Diwali to you all, and all the best for exams. Don't be scared, don't be afraid. Generally, questions are very easier, are of the very similar nature of what we had solved. Week 7 question 9. That's the easiest question, Shrija. That's very easy. don't get confused with this thing. Oh, sorry. Yeah, this is how we are doing it. It doesn't matter agglomerative or any other fancy clustering algorithm they have used. They are merging these 2 points in one cluster. So we are computing their average, and this is our new centroid. No, this was question 10, I think. Question 9, yeah, you mean this? Yeah, this is how we compute it. These 2 points are getting merged together, and their distance is square root of this sum of square. So we have calculated this sum of square, and the distance is square root of sum of squares, no? So square root of 2 is 1.41. So that's the answer. Question 10 is also simple. That also I did tell how we came up with. We are just averaging these 2 points to get the cluster center. That's it. These 2 points are getting merged. We are computing their average to get the cluster center. Okay, we had very nice 13 weeks spent together in solving. All the best to all of you. You will don't worry, you will be able to solve most of the questions, because most of the questions are very similar to how what type of questions we have done till now. You would have noticed that last year's assignments, this year's assignments were also very similar in nature. So, and similarly, the final exam will also be having similar type of questions. So don't worry, nothing new, nothing out of box will be asked in the final exam. So wishing you all the best. Do well. Thank you so much for feedback, like positive feedback. Thank you. My best wishes to you all. Happy Diwali and do well in the exam. And I have shared my email ID with you all. If you have any doubts, if you want to clarify certain things, reach out. I will try to answer. I'm traveling for few days in coming week. I'm going home for Diwali. So in those 2-3 days I will not be able to answer, but I will, as and when I get time, I'll try to answer your queries. Yeah? Thank you so much. Thank you so much, everybody, for best wishes to me also. Thank you. Yeah. So do well, good luck, and thank you. So I'm closing the session now. Yes, take care, everybody. Have happy and safe Deepavali. All the
Thank
best
you,
for
ma'am. Happy
exam.
Diwali. Thank you, ma'am.
Happy Diwali. Okay. Chalo, ending the session now. All the best for exams.